On April 20th, 2023, astronomers using the James Webb Space Telescope made a pretty groundbreaking discovery. They claim to have found 7 galaxies bound together in the highest redshift spectroscopically confirmed protocluster to date, which is just an extremely complicated way of saying they found a little cluster of galaxies that's really young and it's the most distant one so far. It was also spectroscopically confirmed. That's important because it means the light from these galaxies was pulled apart and measured across the entire light spectrum. That makes it the most accurate way of measuring the redshift or how far away an object is. I'm sure you've heard it before, but because the universe is expanding, the farther away an object is, the faster away it's moving. This speed stretches out the wavelength of light that's traveling back towards us. A wider wavelength means a redder light. This cluster averages a redshift of 7.88, which places it around 13.1 billion light years away. Now you might ask how we can even determine these galaxies are in a cluster at this distance, and that's a really good question. It's believed these galaxies are bound together in a halo of dark matter. Astronomers like to use the word halo, it's a cloud. As I said, the universe is expanding, but we aren't because we're being held together by gravity. Since dark matter is thought to have gravity, if all these galaxies existed within the same cloud of dark matter, they wouldn't expand away from one another the same way they would if they were outside of it, so they would be bound together. This is a pretty bold assumption though, because we can't see dark matter, we can only see its effects. Here, the effects of dark matter are seen by the speed of these galaxies. This was also measured using their redshifts, and their speeds don't deviate too much from one another, so it at least seems like they're bound in some sort of gravitational field, which in this case would be the dark matter halo. Just keep in mind that this is based on some speedometer readings of galaxies that are almost at the edge of our observable universe, but this is really the best our current technology can do. One of the coolest things about this study is that it claims if we could see this protocluster today, 13.1 billion years in the future, it would rival some of the largest clusters in our universe. At the time we're seeing it, we can use the brightness or luminosity of these galaxies to give an approximate mass of the protocluster, and the entire thing ends up being around a third that of the Milky Way. But when you calculate the estimated mass of this protocluster right now, using a pretty standard formula, you get a present-day value of around 2.2 times 10 to the 15th suns, or around 1,913 Milky Way galaxies. This assumes that the protocluster will continue pulling in more and more of the surrounding matter and galaxies and build itself up over time. That would put it around the same size as the Coma cluster, which is one of the largest galaxy clusters in our part of the universe. What we're looking at is the starting point for some of the most massive structures that exist. These galaxies also give us some insight into how the early universe behaved. We're finding mature galaxies, protoclusters. The more we see, the more it starts to look like the universe developed a lot faster than we originally thought. It's still possible that this protocluster may never even form into a cluster, or it could form into an even bigger one than we calculated. Unfortunately, we're going to have to wait about 13.1 billion years to find out. We can talk about that when the time comes, so make sure to sub until then.